Hi everyone, today we're going to be doing a sort of different video. We're going to be attempting another speed run on the 3.4 mechanics paper for 2020. So I'm going to try and finish the whole paper in 14 minutes because I need an extra minute to finish talking and ending the video, right? So I'm going to get straight into it. I'm going to try and go answer every single question I can. I'm not expecting to get all of them right, as this is not going to be a proper tutorial video, because I'm probably going to get a couple wrong slightly because, you know, time pressure. So, without further ado, let's go. Start the timer. So, question 1. Draw the force due to gravity and lift force on the plane in the two situations below. Well, Fg is just going to be the exact same no matter what. So, Fg. Lift force is going to be here on this one, Fl, and that's going to be the same size and opposite direction. However, here, because it's on the angle, it's going to be at a sort of right angle degree to the slope, okay? So that's part A done, hopefully. Part B, compare the size of the force due to gravity and lift force on the plane when Tom flies it blah 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 in a straight line and when he flies in a horizontal circle. Give reasons why they're similar. Okay, so if G, compare the size is the same size in both situations. Constant. Downwards. That's one. So the the lift force is opposite and equal to Fg on the horizontal situation, so diagram 1, but if lift has an extra horizontal component which gives the FC, which makes it go in a circle, so overall higher if lift in diagram 2, this one here, because remember we've also got the horizontal component, that's dotted line, okay, that keeps it in the circular motion. Right, on one occasion Tom flies a plane, blah blah blah, mass this, and then this, I'm just highlighting the relevant information. Calculate the radius of the circle. Cool, alright, that's all I need to know. So FC equals mv squared. We don't have FC, so we need to find that, and they asked us to draw a diagram, so we're going to do that. So right, cool, there you go. So this is my F lift vertical, here's my weight force, FC. We need to find this before we can find out FC. This is our FG. So we can, the angle is here, and they gave us the angle, they must have, yep, 35 degrees. So that's the opposite, adjacent, hypotenuse. So we can use the tan relationship. Tan angle equals the adjacent whole, no, it's going to be let's see, over, it's going to be over FG. So if we rearrange that, FC is going to equal well, FG times tan O, so FC equals mg tan 35. So if I put that into my calculator, mg is just, come on, the mass is 7.5 10 to the negative 4 times 9.81, tan 35. Alright, that gave me an answer of 5.15177 times 10 to the negative 3. Is that right? Oh well, whatever, we've got to keep going no matter what. So if we rearrange that, that's going to become 5 times R, so R equals mv squared over fc. I think that's right. So 7.5 times 10 to the negative 4 times 9 times the linear velocity, which is 54 squared divided by the FC. So I've got a radius of, come on, what is it? 424.51 da da da, so I equals 425 meters. Cool, that, I don't know if that's right or not, but we've got to, okay, cool, one's frame, this, cool, so that's just going to be FG, can do mg equals gmmr squared, cancel, g equals gm over r squared, g equals 6.67 times 10 to the negative 11, that's on the formula sheet, times the mass of the earth, which is 5.98 times 10 to the 24, divided by 6.37 times 10 to the 6 plus the height, 1.28 times 10 to the 4. All of that squared. Oh no, we're 6 minutes in. We got to keep moving. 6.67 times 10 to the negative 11. 5.98 times negative 4. And all that's divided by 6.37. 10 to the 6 plus 1.28. 10 to the 4. And all of that squared. Okay, so I got 9.79 as my answer. Newton kg, something like that. Which theoretically makes sense because, you know, we know that g equals 9.81, and that's assuming it's on the surface of the Earth. So if it's at this height above it, the gravity will get weaker as it gets further away from the surface of the Earth. So this answer checks out, so it should be right. Okay, next. 2 minutes on right. Kg radius, this. Angular momentum is 9.18, so I think it might just be this equation. Equals 2/5 kg 60 times the radius 0.200 squared times 9.56. Cool. 5 times 60 times 0. Squared times 9.56. That is going to be 9.117, and that is rounded to 9.8. Right, next. Cool. Explain question. Straight into body, that means the radius is going to increase. Changing our rotational inertia, that will increase our inertia. Comment on our angular velocity, rotational. Cool. So I is proportional to mr squared, where m, we don't give a shit about m. So that means if r increases when she straightens her body, that means the inertia is going to increase proportionally. I don't know why I'm writing all these words out, it's wasting a lot of time. So we're going to assume conservation of angular momentum, no external torques. I know you can't read my handwriting, but I mean you can hear what I'm saying, so it's fine. That means L equals IW. Oh, what happened? Equals inertia. If this is increasing and this stays the same, this has to decrease. So her angular velocity is going to decrease. Rotational kinetic energy is EK rot equals I omega squared. Now, even though I is increasing, this is squared, remember, and this is decreasing, so the majority of EK rot is going to decrease. Right, next. It takes Sandra 0.2 strain her body, her rotational inertia becomes this, so that's the new value we need to find. Calculate her angular deceleration during this time. So we are missing, so we've got the initial angular velocity, which was was up here, wasn't it? 9.56, yep. We know our momentum is 9.18, and that's going to stay the same. Her new inertia is 4.8, and we've got the time, so we just need to find this, because we need to use this formula here. Alright, and we don't have that. So L equals this equals that, which equals 9.18 divided by 4.8. What's that? 9.18 divided by 4.8. That equals 1.9125. So equals 1.9125 minus 9.56. Is it? Wait, hold on. I'll just 9.1825. That's it. Okay. So it's just gonna be divided by 0.280. So the angular acceleration is gonna equal 1.9125 minus 9.56 divided by 0. So it's negative 27, and that negative just means it's going the other way, right? So it's going to equal 27.3. Let's just round it to that. Radians, this. Cool, next. Sandra Toppy does 2 complete somersaults, so that's just another way of saying revolutions. So, 1 revolution equals 2 pi, that means there'll be equal 4 pi because he's 2. Average angular velocity, cool, that's literally just this. Equals the angle of 4 pi divided by 1.25. Chuck that in our calculator. Nice easy question. 1.25. That's going to give 10.05, which we're just going to round to 10.1 radians. Last one, let's go. 3 minutes. Speed running. This equals 2 pi square root of 3, 9.81. 2 pi square root of 3 over 9.81. And that's going to equal 3.47 ... which shows 3.50 seconds next. Explain giving reasons how the period of swing will be affected if she stands up on the swing. So I can sort of draw it out. So this is all to do with the center of mass of Serena. So here is when she's sitting down. Let's say her center of mass here. But when she stands up, let's say her center of mass is here. The sort of pivot point here, as it's closer to the pivot point, right? The length here has decreased, right? So we can say the length of the, well, you can call it the effective length, there's another way of calling it. The effective L of the pendulum has decreased as she's closer to, as her center of mass is closer to the rotating point. We can also, and we're 2 pi, oh no. Okay. T equals 2 pi square root of Lg, but we know that T is proportional to just the square root of L, because this is a constant, that's a constant, so we don't care. So it's just to this. So that means if L decreases, our time period is going to decrease. So it's going to take less time for a swing. Oh no, a minute left. Let's go. Shows. Oh, time's up. Time is up. So, how do I pause this? So, this is what, there was only a minute left until 15 minutes. So, yeah. So, I only got up to 3B. So, we didn't manage to complete the challenge, but we were only 2 questions off. So, we almost got there. Maybe it's because I wasted too much time sort of writing everything down. That took up a lot of time. And also, these, especially like, putting in all these numbers in the calculator takes ages. So next time we might have to adjust that. But I think I did pretty well. I mean, I don't know how I went because I don't have the schedule. Nor do I care because this is a challenge. I just want to see how efficient I am under speed. But yeah, that's it. I thought I'd just do something a little bit different. If you want me to cover this year, like, properly, I will. Just let me know in the comments. And yeah, cheers. I hope you enjoyed the video.